Hello everyone, welcome to this tutorial where we'll dive into a fascinating Arduino project enhances system using interrupts and timers. We'll explore the system components, the use of pin change interrupt.h library, how we adapt our code for Tinkercad limitations, and the overall objective of the assignment. Here's our setup. An Arduino Uno connected to the breadboard. We have three main components: PIR motion sensors, LEDs, and resistors. The PIR sensors are connected to the digital pins 11, 12, and 13, while the LEDs are connected to the pin 2 through 10. The PIR sensors detect motion and trigger corresponding LEDs to lighting up, giving a visual indication of movement. To handle multiple interrupts on the Arduino, we utilize the pin change interrupt.h library. This library expands our interrupt capability beyond the default two external interrupts available on the Arduino Uno. This code snippet shows the pin change interrupts. In this setup function, we initialize the serial communication, set the PIR sensor pins as input, and attach pin change interrupts to these pins. When a change high and low is detected on these pins, the corresponding interrupt service routine, its ISR, is called. These ISR functions set the corresponding flag to true, indicating that the PIR sensor detects motions. In the loop function, we continuously check if any of the PIR sensors flag are set. If a flag is set, it means an interrupt has occurred. The corresponding signal function is then called to handle the event, and the flag is reset. Since Tinkercad does not support the pin change interrupt.h library, we need to adapt our call. So we use the millis function to create a timer that simulates the timer interrupt and will handle PIR sensor inputs using polling. In this code, we use millis to create a timer. When the time file difference exceeds the interval, it prints a message set time file to true and calls the read sensors function. We also poll the PIR sensor states using digital read. If a sensor is triggered, it reads high, it prints a message and calls the corresponding signal function. Now let's execute the code. With our adapted code, the serial monitor logs will look something like this. The serial monitor shows the messages indication which sensor was triggered and when timer fires. It provides a step-by-step log of the system's action. The goal of this assignment is to push beyond the default limitations of the Arduino interrupts by using the pin change interrupt library. We can capture interrupts from multiple pins, which allow us to handle more than the default two external interrupts. This is particularly useful when working with multiple sensors. The challenge here is to manage these interrupts efficiently. Instead of having an interrupt for each pin, the pin change interrupt dot library groups the pins and manages them together. Accordingly, we have additional the time interrupt using the millis function which fires to regular intervals to perform tasks like turning on an LED or reading sensor data. With this setup, we have successfully managed to handle multiple interrupts and timers, demonstrating an advanced use of Arduino capabilities. By pushing beyond the limits, we can create more complex and efficient systems.